Hello everyone, and we have a new circuit here. This is our new circuit. We have the buzzer, the LED with some resistors, transistor, LED, push button switch, and a header, some jump wires, perf board connected to a 12-volt supply. This is our new circuit, and this is transistor buzzer circuit. We also have this previous circuit. This is also a buzzer circuit. And we have this. This is a 555 timer buzzer circuit. So we have the buzzer circuit, also a buzzer circuit. The only difference is we're using the transistor here. This, we have not transistor, and this, we have just a 555 timer. This is an automatic buzzer circuit. This is a manual buzzer circuit, and this is also a manual buzzer circuit. Let us see the circuit diagram of our new circuit. This is a transistor buzzer circuit. We have the 12-volt supply, we have the switch, we have the resistor, the LED T1 to the ground. This is a power on LED indicator. Upon closing the switch, LED turns on. There's no light here. When you close the switch, there's a light. Also, we have the push button connected series resistor with an LED T2. This LED is an input LED. Every time you push the switch, LED turns on. This green LED. This yellow LED is this standby power on LED. We also have this resistor at the base of the transistor. I'm using BC547B NPN. Q is the symbol of the transistor. We have the collector, base emitter junction. Emitter is connected to the ground. At the output side or the collector side, I have the buzzer, the LED, and the resistor. I'm using resistor here to protect the LED. This is our output LED, the red one. Every time you push the switch, LED turns on. Connected is in series with the buzzer. Positive side of the buzzer is connected to the cathode side of the LED, and the negative side of the buzzer to the collector side of the transistor. This is our new circuit, and this is our previous circuit. What's the difference between the two? It has a transistor. It has no transistor in this circuit. Let us see the circuit diagram of this. This is a buzzer circuit. Just a normal ordinary buzzer circuit. The same with the LED power on indicator, the yellow one. Also has a push button and the series with the buzzer resistor LED, output LED, the red one. Every time you push the switch, the buzzer buzz sounds. Since this is our previous circuit, and also we have this a 555 timer buzzer circuit. This is automatic buzzer circuit provided by this 555 timer that serves as a clock to produce this automatic buzzer circuit. Unlike these two, they are manually operated. This one, a simple buzzer circuit, and this is a transistor buzzer circuit. Let us see the circuit diagram of this 555 timer buzzer circuit. So this one is a 555 timer buzzer circuit, and the buzzer is connected to the pin 3 of the 555 timer chip in series with the resistor and an LED. Previous circuit, also a previous circuit, and let us discuss the current flows of our new transistor buzzer circuit. So let us examine the current flows. So we are connected to the voltage supply 12 volts, that is our previous circuit. And then the switch, when we close the switch, LED yellow turns on. That is a power on LED indicator. It means the current flows from positive to the switch close to the resistor RD1 and to the LED D1 to the ground, making a first KBL in this loop. Current flows also up to here, but the transistor will not conduct. It will operate in cut-off mode because the push button is normally open. There's no triggering current at the base of the transistor. That's why the transistor is conducting in cut-off mode. There's no collector current here because there is no triggering base current at the transistor. So when you close the switch, KBL, at the blue line, we have this formula. Closing the switch, KBL at D1. KBL is Kirchhoff's voltage law, sum of all voltages in a loop, closed loop, is equal to 0. So voltage supply minus the voltage drop at the RD1 at the D1 is equal to 0 according to KBL. Transposition, substitution, and since we have this voltage rating of the diode, I'm using 2 volts for the voltage rating of the diode and the current rating of the diode 0.02 ampere. This is a standard value for computing the diode LED to turn on the LED. This is according to the data sheet of the LED. So we have now 10 volts. The voltage drop across RD1 is 10 volts from KBL, first KBL here. Since we know the voltage drop across the RD1 and we know the current rating of the LED, we can now use Ohm's law. Voltage is equal to current times resistance to compute for the value of the resistor. Transposition, substitution, since we know this in the datasheet of the LED, to turn on the LED is 0.02 ampere, 10 volts. We got now the value of 500 ohms. So we are using resistor here to prevent the LED from burning, to limit the current flows. Closing the switch, there's just a first KBL happening in this loop. Since there's no current flows here at the moment, we have first KBL here. Upon closing the switch, pushing the button, current flows from voltage supply to the switch, to the resistor, and to the LED D2. D2 here is the green. The LED here is an input LED. Every time you push the switch, LED turns on. The resistor will serve as a current limiter to the LED to prevent from burning. Every time you push the switch, current flows from voltage supply, switch, resistor, LED to the ground. Also, when you push the switch, current flows also here, conducting the transistor in saturation mode. Since this is our objective, to use transistor in saturation mode, to conduct in saturation mode. Current flows to the resistor and to our output LED, D3. That is the red, the big LED red, in series with the buzzer connected to the collector side of the transistor, BC547B NPN. Q, that is the symbol of the transistor, and the negative side of the buzzer is connected to the collector side, the positive to the cathode side of the LED, anode side, the resistor. So they are connected in series to the collector side. Every time you push the switch, LED, the input LED here is turning on. Also the output LED here is turning on. This is a big red LED, 10 millimeter size. So this is turning on the output LED, and the buzzer is buzzing, and LED, input LED is also turning on. The green, the red, and the buzzer. Let us compute for the value of the resistor to limit the current in the LED, input LED. Since we are pushing the button here, current flows here to the ground, making it a second KBL, the green one. Voltage supply minus voltage drop RD2, BD2 is equal to 0, the same using KBL. And transposition, substitution, the same, since the voltage rating given in the data sheet, 2 volts, 10 volts. We now know the voltage drop across the RD1 is 10 volts. Also the same here, 10 volts, 10 volts. Since we know the current rating of the LED in the datasheet, we are now using Ohm's law. Voltage, current times resistance. RD2 now is equal to, by transposition, substitution, we got now this 500 ohms. Same as RD1, RD2. They are both 500 ohms. So the next one, we are going to use this base transistor, the transistor, a resistor to protect the transistor from damaging. We have this resistor base resistor. In order to know the value of the resistor at the base, we need to calculate the value of the current flows of the base current, and the voltage drop across the resistor. To calculate the base current of the transistor, we use this transistor current gain formula, or HFE, is equal to IC over IB. This is a transistor formula. Transposition, we got IC over HFE, Q. IC here, current at the collector, is also equal to 0.02 ampere. Since the current in series is equal, this is also 0.02 ampere. The collector current is equal to the current rating of the LED because they are in series. So we get now by substitution 0.02 ampere, the IC, and the HFE is 200. The HFE of the transistor is given in the datasheet, 200. Calculation, we got 0.0001 ampere. We got now the base current of 0.001 ampere. How about the voltage drop across the resistor at the base? We can calculate the voltage drop by using the KVL. Just to turn on the transistor, we need this KVL, voltage supply to the switch, to the base resistor, and to the base emitter junction of the transistor. So we got voltage supply minus transistor at the base minus the base to emitter junction transistor. We get by transposition, substitution. I use 0.9 volts for the voltage drop across base to emitter junction of the transistor because it is given in the datasheet of the transistor, 0.9 volts. To turn on or to conduct transistor in saturation mode. Voltage supply minus the voltage drop across the resistor minus the voltage drop across the base to emitter junction of the transistor. I got now 11.1 volts. Since I know the voltage drop and then the base current, I'm using Ohm's law again by substitution, calculation. I got 111,000 ohms or 111 kilo ohms. That is the value of the base resistor to prevent the transistor from damaging. Since we know the value of the RD1, RD2, RB, we now come to the output side. I'm going to use an KVL again because the current flows here when you close the switch to the ground. KVL PS at D3 minus the voltage drop across the resistor, diode, buzzer, transistor, collector to emitter junction of the transistor. Transposition, substitution. We got here the voltage supply 12 volts, voltage drop at the diode 2 volts. Also, voltage rating of the buzzer is 5 volts. That is given in the data sheet of the buzzer, 5 volts. And then the data sheet is also given here the transistor collector to emitter junction is 0.2 volts. That is given in the data sheet of the transistor, 0.2 volts. Calculation, we got 4.8 volts. That is the voltage drop across the RD3 to prevent from damaging this LED. I got now, by substitution, using Ohm's law, again, since we know the voltage drop and the current rating of the LED, 0.02, I got now 240 ohms, or I'm using 220 ohms available resistor. So, we are successfully completing the design. Pushing the button, transistor operates in saturation mode, almost shorted, and we have this output LED turns on. Every time we push the button, input LED turns on, and also the output LED turns on, and the buzzer is buzzing. Standby LED, input LED, output LED, and the buzzer. Let us see the simplified equivalent circuit diagram. So we now have the value of 500 ohms, RD1, RD2, 500, RB, 111 kilo ohms, RD3, 220 ohms, and we have this layout. I'm using this layout, the buzzer, the LED, resistor, transistor, resistor. This is a header for my voltage supply, LED, and the push button. I have also the parts here, the buzzer, some LED, resistor, transistor, resistor, LED green, yellow, perf board, jump wires, header. So we have now this new circuit, a transistor buzzer circuit. And we are using transistor to conduct in saturation mode. Unlike this one, this is a normal or ordinary buzzer. Push button is connected in series. This one is 555 timer, an automatic buzzer circuit. Okay, thank you for watching the video. Bye bye.